Hello everyone, I hope you all are doing well. So today I came up with HyperWorks, that is Alter HyperWorks. Here I'll be covering the tutorials from basics to advanced level, starting from the user interface to static structure analysis, buckling frequency, non-linear and all, using the OptiStruct and the radio solvers later on. In this session, I'll be covering the basics of structural analysis using the 2D mesh and user interface and how to deal with the different types of shortcuts, and we'll see how the tools are utilized to work on the analysis process. Let's get started with this. Yep. So if you need to start the HyperMesh, so you need to directly go to search. From here you can search for HyperMesh or HyperWorks. You'll get it. So if you move to the file locations, you're gonna have this all the applications, the workbench. So HyperWorks, which will help you to model the components there, and HyperMesh will help you to just make the analysis in that particular workbench. So if you want to use it frequently, you can simply right click on it and you can use the pin to taskbar option. So it will be pinned to your particular taskbar so that you can just click on that icon every time. So simply double click on the HyperMesh 2022 so that the workbench will open. So while opening this workbench only, you'll get the default notification to choose the solver to run the particular analysis. Yeah. So you could see these are the user profiles. So application by default, you can choose the HyperMesh. There are different basic applications are also available. So default, it will be a HyperMesh. So this radios will help you to analyze the advanced analysis like the nonlinear explicit implicit dynamic analysis and crash analysis and all by using this radios. So OptiStruct will be used to deal with the linear analysis, normal frequency analysis and all. So if you want to just check more details about it, you can just directly go to the help tab, and from here you can choose the HyperWorks help hole. So here this particular website will help you to learn each and every tool by just searching what exactly you're looking for. So you could see we have the HyperMesh, HyperView, and then we have these all these resources and the OptiStruct, why we use it, radios. This is for explicit dynamic solutions. Structure analysis and optimization, we use the OptiStruct. Okay, so keep on, you can just see each and everything is available here only. So if you want to access the tutorials and the other things, everything is available here. Well, I'll keep it as it is now. I'll choose the OptiStruct and just to introduce how the user interface will be, and what and all the tools you can use and how to use them in the beginning. So this is just a basic session, so we'll get to know about the entire user interface. Well, let's start with this. So as you could see at the top, you'll be having the menu bar. So for the files, you can able to import the model, geometry, and the sessions. So if you already created, and then we have the different tabs. From there, we can able to access the tools related to that particular uh, features. So constraints, material down like tab. There you can create the materials. Okay, so then we have the model tab wherein all the steps which you're gonna just create will be stored here. Okay, so these are the tools, the quickest tools, the masking and unmasking tools and the find tools and all, so available here. And when it comes to the bottom of the tab, you want to see these are geometry, 1D, 2D, 3D analysis tool and post. So these are the processes which we're gonna follow to deal with the analysis stage. So if I switch to the geometry, I'm gonna have the a few tools to select the nodes, create the nodes and lines and surfaces if you want to delete them. So these tools will help you. So this is regarding 1D mesh. So we can use the different types of uh, tools which are available in this 1D, that is bar, rods, rigids. To create the rigid body connections, we can use the rigids, RBE3s, springs and all the connectors, spot weld. So everything is available here in this. When you can create the joints. Okay. When it comes to 2D, we can able to create the 2D mesh, okay, by using this AutoMesh options, and we can just deal with these all the tools here. Even you can just modify some things like split the faces, replace and attach faces and all. So here you can do it. But so we have the 3D there. We can able to deal with the 3D meshing capabilities like tetramesh and other connectors. If you want to define, you can use them. Okay. Mapping is available, solid map and linear solid and solid mesh. So these are the options you can have it here. When it comes to analysis, we have the constraints and force definitions and even the moment and pressures, load types. So these all the things here you can able to define. When it comes to tools, so we have the tools like the masking, deleting, reorder, translate, element check. So once you measure it, you need to check for the aspect ratios, Jacobians. Okay, it will be done by using this check element tool. So then after that we have the numbers. So renumber counts the number of nodes if you want to count. Okay, if you want to just number all the nodes, you can use these options. Okay, quite advanced tools, and just go through these things, just the basics. Okay, don't worry about these things. So while working on the user interface and the HyperMesh, and get to know about these tools, how to use them and how to work on these things. Finally, these are the few of the post-processing tools. So result, counter visualization, vector plots and all, deform shape, scaling the plots, so XY plots and all. So here you can manage these things. I hope you got these things. So here a few of the options are there. Let's say if you want to carry out the particular analysis, there are some steps to follow. First thing is we gonna create the component. Okay, the by default the component will be created once you import any of the model inside the HyperMesh. So once the component is created, so this is just a basic component. Okay, later on you have to assign the properties for this particular component. Remember, that is very important step in the analysis. That is the by default components will be created. If you want, you need to create the new component at the last and assign the properties for this components. Once you are done with the components, we apply the materials. So practically we consider this as a first step, that is applying the material. So once you apply the material, we'll go with the properties definition. So there we assign the solid type, but it is a shell or it is solid or it is p solid or p shell, what is the thickness, everything. Even the material will define for the particular property here. So here in load collectors, what we do is we apply the load collectors. Like if you're going to assign the SPC, a single point connectors, so and then the fixtures, loading conditions, boundary conditions and all. By using this load collectors, we define the load collectors first. Inside it, we'll apply the constraints on the loads and pressure required. Okay, so these are the few steps. After that, we're gonna create the mesh by using any of the mesh, 2D mesh, 1D mesh or 3D mesh. Once the meshing is done, we go with the applying the constraints as I said, and then once that is done, we'll apply the load step, which is very important step in the particular analysis, where we define the which analysis we are going to do, static or buckling analysis or model analysis or frequency, whatever it is. So we define the load step. Once you define the load step, we run the analysis, what exactly we have selected as the solver, like OptiStruct or radios or whatever it is. Well, so once these things, I hope you got to know about these things. So this delete tool will be used to delete the particular features or whatever you have applied. Okay, from here you can just switch to the HyperMesh, HyperView, and whatever the workbench you're looking for. So this is the quick switch app tab you can consider. So this tool will help you to like get the component model view with respect to the assembly or 2D or topology mixed or mappable like this for by component by part. So you can switch the model type. Let me just show how it works. So what you can do is, let me just import the model. So you can use this option import. From here you can use the import geometry. The best shortcut is you can switch to this file, import geometry. So here you can just clear all the recent histories by using this clear option, and here you can select the file type. So HyperMesh HyperWorks, this particular workbench will help us to just quickly access SolidWorks file, step files and VDFS files and all, random files as well. So these are the formats which are supported with this. So right now I'm going to import the step file. So I'll just select this step like this, and from here I'll just open the location. I'll select the desktop. So I'd like to add the step file. Open it. So it is added here. If you want to make some changes into this, you can use the import options. So what exactly you want to extract, the surface or solid body, whatever it is. I'll click on import now. So once I do that, the model will be imported to the workbench. Now, very important things. The first thing is these tools we need to know. So these are the orientation tool. The first one is the this is reversing. So this is select plane orientation. This is XZ like this. So we have the YZ orientation, and then we have the isometric view. Okay, so these are the orientation. So this will reverse the view. Let's say this is my front view. If you want to reverse it, you can use this tool. Okay, now I hope you got these tools. So this is zoom to fit. So let's say if you uh, scroll away, you can simply press F, or you can click on this particular zoom to fit tool. So in this you can split your windows, so multi windows and all you can switch like this. So here, like if you want to deal with some other post processors like previewing the results and all, here you can do it. Here you're gonna create the hyperview for the result processing. So I'll switch to the single window, so it will come back to the normal view. Remember that. Well, so I hope you got these things. Now when it comes to this options, this is zoom in and zoom out. Okay, this is for F key to zoom fit, again the keyboard shortcut. This is for dynamic move, like this. You can move it. If you don't know these shortcuts, or if you're totally new to this, you can use these tools. Okay, initially these will face difficulties and work on this user interface due to this particular complexity. So these tools will help you to deal with that. So this is for planning, this is for rotating like this. Okay, well, I'll set it to isometric view. Now these are the display like navigation tools. When it comes to the shortcuts, concentrate. Control and right click drag will help you to pan the component. You can drag it along the graphics area, the model. Okay, again same control, left click and hold and drag will help you to rotate your model however you want. Okay, remember that. Now if you want to zoom in and zoom out, again hold the same control, use the cursor button, zoom in and zoom out, roll out and roll in. Okay, this is for zoom in and zoom out. Now very important step, I'll switch to XY plane. Now sometimes selections might help. Let's say I want to select only these, like once you mesh it, I need to select only these elements. So for that you need to hold the shift and drag. So right now it doesn't work because we didn't add any of the mesh here. So let's do that one. Okay, the basics I'll let you know. Well, so these are the different display options. So this is mixed. If I select it, it will take everything. Okay, the edges and all, everything it will consider. Well, so I'll switch the model tab. As I said, so by default, whatever the geometry you're gonna export, that will be created as a component. There won't be any properties assigned to this. So you could see no properties assigned, no material assigned. These are the very important steps. Okay, we need to assign the property and the material for the component. Later on, I'll showcase. Well, so we'll start by one. So first step is, I personally recommend you to create the material. So to create the material, you simply right click here and use the create option. From here you can create all the things what are indicated here. So let's say I want to create the material, click on it. Shortcut it is, or else you can use the formal way. Just click on this material. So it will directly take you to the material creation tab. You can name it steel 1. Okay, and if you want you can assign the color. Let's say I would like to add the pink for just a reference. The type, so which kind of material you are looking for. So anisotropic or a fluid or orthotropic material or hyperelastic materials or what. So I'd like to go with the isotropic properties here. Okay, so card image, it is matte 1. So there are two options in isotropic. One is matte 1 and matte 4. What are these? So if you like, you will face this kind of queries or confusions or the things you don't even know about these things. So how to know about these things? As I said, you can use the same tool help, and here you can search for the matte 1 and search. Okay, you could see once you search for the matte 1, you're gonna have these things: matte 1 in OptiStruct, material property check for matte 1. So let's say I would like to go with the first one. And this you could see all the details with respect to the matte 1, matte 2, matte 1, 2 EC, everything is available. So let's say if you're going to select the matte 1, so you can able to define these properties like the linear, temperature dependent, and then the isometric properties in matte 1. Young's modulus for E, G is to uh, modulus of rigidity, and rho is the density, Poisson's ratio for NU. So if you want to see here, you could see E is Young's modulus, G is the shear modulus, and Poisson's ratio, rho is the density, thermal expansion coefficient is the E, G is the damping coefficient. Remember, this one is very important. Later on in nonlinear dynamic analysis, we're going to use these. Okay, this is about matte 1. You got it. So what about matte 2, matte 4? So matte 4, it will be used to deal with the thermal analysis, that is to deal with the conductivity, density, and heat generation. So same thing can here define it. K is the thermal conductivity, Cp is the specific heat coefficient, and then rho is the density. This is heat transfer coefficient and all. So this will help you to just deal with these all the things. So this search you can use it later on. I hope you got this right. I'll create the material. So don't click on the create. If you click on the create, you need to right click and edit the material again. So better use this option, create and edit, so that it will directly take you to the edit window. There you can enter the other properties, mechanical properties. So I'll click on this create and edit. So this particular image card will help you to enter the properties. So matte 1, so Young's modulus, as I said, we need the main things for static analysis is Young's modulus, Poisson's ratio, and the density. So first I'll simply click on this E icon. So automatically the HyperWorks or HyperMesh tool will record the steel properties in the form of Newton ton. Okay, so let's say density in this, and we have the Poisson's ratio. Okay, well, so once you extract these things, so again I told these are the properties. Only these are required for my static structure analysis. I simply click on return. So if you simply click on create sometimes, what exactly you need to do? So by default, this will be created. Right click on it and use the edit card. So it will take you to the same workbench. You can enter the values or make the changes anytime. Okay, so once the material definition is done, so you can go ahead with the next step is to create the property. So click on the properties or else right click here and create property from here. Both are same. So once you create it, you can simply click here or else you can right click on it and edit the card. So it will take you to this workbench to edit these all the things. So what and all things we need to add here. So here we need to assign the material. If you click on this tab, the previously created material tab will be there. Just click on OK. And then we need to select the P shell or P solid. So as we are dealing with the which type of material solid, we need to use the P solid. So what about these things? So I don't know, right? So what you can do is, so this is one step. Okay, this is one kind of property assignment. So not like I won't suggest you to use this method. I prefer just click on this property so that you can directly get this input tab so that you can directly enter. Let's say here you can assign the property name. I'd like to add static analysis complete. Okay, so this is the property. The color you can choose, and here the type. So what exactly this particular component is. So I'm going to deal with the 3D, right? The 3D model it is. I'll use the 3D. And the card type. So from here we have the P solid, P cascade, and we have the PLL solid. So I'll select the P solid. Material, if you click on this tab, whichever the material you have created, it will be shown here. Just click on this. So like this, it will create. If you simply click on create, now you could see there is no property tab. Now click on it, it will create. Right? Like this, you can create. Now I would like to search for the P solid. So I'll go back here. Let's search P solid. And P solid in OptiStruct. Selected. You could see these are the expression. This defines the properties of solid elements referenced by these things: C penta, C picra. Okay, so PID, unique element property definition, MID, and etc. Full integration of the same integration as linear applications and all. So this is related to 3D elements. Okay, P solid. P shell is with respect to the shell elements, 2D elements. Fine. So you can even deal with these all the things, RBGs, and also later on you can just check these all the things. So right now, even SPC is very important here. I'll simply select this SPC. So I'll let you know what exactly it is. So it is a constraint definition. So this is for the bulk data entry. This is known as single point constraint for the displacement in the structural analysis or temperature boundary conditions in the thermal analysis. Same thing. So you can see these are the options. I hope you got this. So let us see now how it works. Well, so instead of selecting entire solid model for the analysis, the basic analysis, I would like to take only the slice of it. What you can do is, from this particular solid, you can see the component only one is there, right? Switch to the geometry. So I'd like to create a surface for this mid surface. So I want to extract the mid surface. So you can switch to the geometry tab from here. I hope you could see this cursor, right? From here, you can choose this mid surface. So there are two ways. One is auto extraction or extract options. If you select the face, it will help you to separate the faces manually. So I'd like to go with the Autodesk extract. This is the entire solid. In the option we have the surfaces as well. So I'd like to select the entire solid as it is simple solid. If I simply click on extract, it will create the mid surface for this. So I'll return, and now you could see mid surface got created. Now you can hide this particular solid model, right? Now I'd like to create the 2D mesh for this. So if you're going to use the 3D model, you can use the same model, and that particular thing I had covered in the later session. You can see the video, the next tutorial. At the moment, I'll only restrict to this particular 2D, and here we have the auto mesh option. You can select it, and here with respect to the surfaces, and select all the surface. So it is a selection drop down. You can use it. So from here, what options? Size and bias or element size, you can define it. So mesh type. In this we have the quad, trias, or mixed. So I'd like to use the mixed. Okay, and here I would like to use the second order, so which will give me the better mesh quality. So first order elements and second order elements, please Google it and get to know about these things. Well, so I'll simply click on mesh. So element size, I'll take it 0.5. It's a mesh it. This is the thing. So let's see, it will be added here. So this is how the mesh looks like. So yeah, so once the meshing is done, you can return. You can go with the next steps to assign the properties is done. We need to assign the load collectors. I'll simply click on the load collectors from here, or I'll right click and create. Can use it. I'd like to use this and a specific show. I'd like to name it as SPC itself. Name it as F. Color red, I'll use it. I'll simply create. I would like to use the load. I'll type it, and the color I'd like to use blue for this. Create. Now these are the two load collectors which we have added. Now here you could see the load is active. If you want to activate the fixture, right click on it and use make current. So whatever the changes you're gonna do now, I'll return. It will be updated into this. Let's say I'll go to the analysis. I'd like to add the constraints now. SPC. I'll click on it, and it will ask you for the selections. So here I would like to select the nodes. So like how? If you simply click on this option, the nodes tab, it will take here. I would like to use the bypass option. Okay, so here I'll select this point, and if I just use same path, it will select all the nodes along with this. Or else you can use the shift and drag the cursor like this. So this is also one way. Hold the shift and left click, draw a rectangle like this. Or else you can hold the shift, double click, you can get this. From here you can select circle, filtering, outside circle like this. Remember, so I prefer use the rectangle only inside rectangle by default. Hold the shift and double click to activate that particular selection tab which you want to choose. Remember this. Well, so right now I'm not using it. Let's zoom it. I'd like to zoom in at this location so that I'll simply do the selection so that it will select all the nodes on this. So here I'm going to consider all the DOF 1, 2, 3 in this region XYZ. This is rotation along XYZ. I would like to constrain all the things. So I'll simply click on create. So this is the indication. So here you can use the relative size to 1 and again review. Let's see. This is how it creates. So this is the relative size for this fixture indication. Once you're done with this, I need to apply the loading conditions here. So we can return. Fixture is done. Remember, I need to switch to the load. Right click on it and make current on the load. I can switch to the force. I'd like to again select the node by how, same thing, by path. or else you can create the rigid body constraints field. Later on in the later session I had covered it. Please do watch that video so that you can understand how to, like, if you're going to deal with the solid meshing, there you need to select the 1000 to 10,000 elements or nodes, so that is quite difficult, right? So for that we create the rigid body connections, that is pseudo nodes, and that pseudo node we will link to the all the nodes on the reference faces that you can see later. Well, so here I'll select this node at the corner. Let me just see which node got selected. Yes, this is fine. So I'd like to zoom in here and I'll select this point. So all the elements, so magnitude 10,000 Newton, I'll select. But this doesn't work here. Okay, there are totally multiple elements. Now how to know that things? First thing is I'll simply create it first. It is too big. I'll again make it to 1 a little bit. This is fine. How to number these nodes, how to count them? So shortcut is you can simply click on this load. It shows 201, right? So 201 divided by 10,000, 10,000 divided by 201. If you do it, you'll get the value for a load for one particular node. So I'd like to divide 10,000 divided by 201 node. That is 49.75. So if you want to edit this particular thing, just make it active. Just again switch to the forces. Here you can enter the value. That is, I need to update it, right? Click on update, and here it is 49.75. Can even add 124 as well, so for better accuracy, and update it. Okay, written. So we are done with the boundary constraints, loading and all. So next step is to define the load step. So here only we have the load steps. Just select it. From here you can just name it the static analysis on plate 2D, right? So here in the SPC, I would like to select the boundary condition, that is which we have set the fixture. In the loading condition, by default it won't be checked. You can just need to check this option. These two are important for the static analysis. I'd like to select the load here 2. And in the analysis type, so these all are the analysis which are available in the OptiStruct: linear analysis, frequency, fat elk, buckling, nonlinear buckling, and okay, explicit analysis and all. Okay, I'd like to deal with the linear static at the moment. It's done, right? Created. Load step will be created. Again, return. We are done with the load step creation. So final step is to assign the properties to this component. So just select this one. You could see there is no material and the properties has been assigned. So you can create the new component, or else you just simply right click on it and assign the properties for this only instead of wasting the time. So just select this property drop down. You can use the static analysis and plate and apply. So you could see for this property and the material got assigned. Okay, well, if you want you can delete this, but right now I would recommend you to keep it here only. So we are done with all the steps here. So final step is to run the analysis. So from the analysis you can use the OptiStruct, and here you define the location where you want to save it. So I'd like to save it somewhere else. I'll go here. I'll create a new folder, 2D structural analysis. Okay, so here plate with hole 2D. Fine, I'll save it. Is the location now. Export options in the all, you can just use all the results should be extracted. Run option, don't use check by default. Sometimes it will be check. If you run the check, it will only check each and everything. Analysis, if you select, it will run the analysis. Remember, I'll use the default, and I'll simply click on OptiStruct to run the analysis. Remember, there is no run option. You just need to click on the OptiStruct. Once you click on it, it will directly take you to the run wizard, and by default it will run the analysis. But we have the error, right? So the error is error 14, missing property. say quad 8. So what might be the reason for this? Actually, the thing is, we have used the solid model before, and we have defined the property as p solid, right, for tetrahedral elements. And now we are running the shell mesh, isn't it? So we need to change the properties to p shell. So sometimes, if you're the beginner while dealing with these all things, you might get this error. So I have purposely created this error so that you could know what exactly you need to do here. Okay. So you can just switch to this properties, and here you could see the p solid is active. So if you simply right click and edit this, you won't get the editable tab here. To make the changes, you just need to return and click on this, and from here card image you change it to p shell. Okay, once you do that, it is into a shell 2D. You need to define the thickness as well. So you have this option T here, just define the thickness as 5 mm. Okay. So if you simply again right click and edit the card, you will see this particular option here, the thickness got added. Okay, as we are using the shell mesh 2D element, so we need to define the thickness. Very important. Well, so once you do that, you can simply go to the OptiStruct from the analysis and run it. As we have run the analysis before, it will ask you for the override the result. I'll do the same thing. Okay, so these are the basic steps you need to follow. Here, have selected the 201 nodes, and I have distributed the loads on each and every node. So this is not appropriate, or this is not recommended. So to run this kind of analysis, we need to define the rigid body connections, and we need to define a particular node, and on that node we need to define all the multiple loads. I'll tell you why we need to do it. So I'll just switch to this hyperview. Okay, you can even use the hyperview from the output option only before closing the tab, and it will open the independent workbench that is for hyperview to preview the results. So you can use the XY plane, and I'll go to the 𝐂𝐀𝐄, and you could see this is the location where the file got saved. You can simply apply it at the moment, and now I'll use the 𝐂𝐀𝐄 plot, and from here the displacement plot I'll apply. And you could see the displacement is 4.3, but practically for 10,000 Newton loading condition, this won't be the displacement. And even we can see the animation for this. You can just reduce the speed by using this dragger here, and you can just animate this. This is the displacement plot. You can even have the different plots in the result type. You can use the drop down here and select the stress plot 1 minus by default, and this is the result. The values are quite high. Actually, practically this is not the case. Okay, so whatever the load we have applied, the process, the method which we have followed is quite inappropriate. So now, even to avoid this, what we need to do, I'll explain here, because while doing the simple basic analysis, some tutorials or some people have showcased the same thing. Just select the nodes and distribute the loads equally. Instead of doing this, you can switch to the workbench one by just using the arrow mark at the right corner. Now here, instead of these distributed loads, what I'll do is I'll switch to the model. I'll create the rigid body contact. So I'll switch to the geometry, and from here I'll create a pseudo node so that I can distribute all the node to that particular node, so that you can have the single node loading condition. So you can switch to this, and from here line extract point, that is node on line, and I'll select this line and create. Now to show that, I'll hide these load collectors and the mesh for now. And you could see when you zoom in, you'll have the pseudo node got created. So after this, I'll switch to the 1D, and I'll create the rigid body contact now. So the node as independent node is this, and here the dependent nodes are these. I'm going to select by path now. There are multiple options, so here I need to select only the corner edges, the corner elements, sorry, the nodes. For that, I'll just zoom in. The mesh you can activate, and by like if you just select the points like this on the same line, by default it will select the same thing. Let's say you can see if I zoom in and select this particular point, the nodes will be selected along with the same path. I'll do the same thing at this corner as well. You can use a shortcut. I'm using the same thing, that is control and right click button. Okay, left click button, sorry. Yep, so done. All the nodes got selected. Now I'll simply create it. So now we have created the rigid body constraint. So this particular RB issue, I'll use it to define the load. So now initially I had defined this load collector. I need to delete it because there you might not able to edit these all the things. So I'll recreate the load collector again. So this is okay, there is no issues with that. So I'd like to switch to this again, load collector. I'll use load 1, load 2 this time to avoid the issues. So create it, and here it is active. You can switch to the analysis from here, force. Now I need to create it new. To create, and node is this, just select it, and the load magnitude is 10,000. Okay, so along x direction we are applying the loading condition. So this is fine, and you could see the preview. So once you create it, you will have this. Let's see how this particular results will give us the outputs. Well, so now you need to make few more changes in the static study. If you edit this, you won't get the editable table here. So you need to define the loading condition. So just click on this, and in the bottom here you can just select this and click here. You'll get the selection method, that is load to. From here you can able to change it. So once you do that, you can switch to the analysis and run the analysis, and now we'll see the results. So you could see the job completed. You can close it. You can switch to the hyperview, and here if you just really use this tool here, XY plane, and the displacement, you could see it is 0.021, and the 1 mass stress is 124 megapascal. So this is what the results we expect. Even the 3D element which I had done, see approximately the results are quite matching. So these are the basic steps you need to follow, and yep, that's all about the session. So in short, to summarize, we have gone through the basic steps and the shell elements and the user interface, introduction to each and every tools, how to use them, and how to search about the tools or the terms which we don't know. Okay, and few common errors, how to avoid it, and if you make the changes inside the particular process, how we need to operate in each and every process. So these things we have seen. I hope this video might help you to understand the basics of HyperMesh if you're the beginner. Well, that's all, guys. Thank you. Stay tuned. Bye, everyone.